So, if there are no more issues, you should all got the debugging output of our accelerator. So what we see at the beginning is that in the first kernel we start transferring 10 items. They are listed already down below here, so there are there are the arrays. We've also mentioned the sizes of the arrays and also other variables. And then, I mean, to summarize that one, we have the line down here, which sums up everything. So we see we have here, what's that, 480 megabytes of data transferred for the first kernel to the GPU. Then we see here is the kernel executed. It mentions which kernel it is and which line we find it, and also how it's distributed. So it's 128 threads. Also how it's synchronized, and here's the source code file also. And then afterwards we see the transferring of data back from the GPU to the CPU. So we see here in the summary that it's around 33 megabytes copying back. So this is our first kernel. Then we're transferring again 480 megabytes to the GPU. We have here the next kernel, and then we're transferring back data. So, and then we do again and 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 again, and that's a lot of data we transfer forth and back. So that's the reason why we spend so much time in data copy. But how to prevent that? Anyone? Any idea? Let's have a look back to the code. So, right, that's our kernel, right? And around our kernel we have here, oh, yeah, you see it. We have here our iteration loop. So could also do now on our output file a grep for the execution of the kernel and do a counting how much this is done, and we will see it's 1,003 times done. So we have 3 times the iteration loop for the initialization. No, it's not initialization, it's how we call that, adjusting the computation, and then we have 1,000 times that examples the iteration loop done for the actual computation. So 1,000 times we call that kernel here. We call that kernel with these 3 loops, and each time we copy all the data from all the arrays forth to the GPU, and at the end of the kernel back to the GPU. Is it really necessary? So what we do within our iteration loop, we have the kernel computation here, and then down here we update our actual array P. Then we act on Goza again, and that's it. That's the end of our iteration. So we do more or less nothing on the CPU with our data we compute on the GPU. So I would suggest, and that would be the next point on my presentation, what we first could do, we could prevent copying data which we do not need on the GPU. So we could really do data scoping, and we could realize, okay, for example, array P, which is not updated here within our kernel because we work on these temporarily variable work2. We updated just P later. So we just need to copy in here. So we save half of the data transfer for P. Same we could do for work, we just need to copy out, right? But we could think of, and we could do the same for also the other variables. So we could do a specific data scoping for all our variables.
Did you say before that it is repeated as many times as the...
Okay, that would be the next step. Excuse me, I was too fast. All right, that would be the next step. So I would suggest first doing that, and in the next step, since I already mentioned that one, I would suggest, we saw that already, I would suggest to put a data region around the iteration.
No, but I wanted to ask, it appears to be, did I understand correctly that you said that so the loops repeats 10,000 times, and that's how many times copying will happen?
So, okay, I mentioned that we have here our kernel computation, or our iteration loop, right? Which is called, for the actual computation, 1,000 times.
Is it the outer loop, or?
This is the most outer loop. So there's, okay, let's go back to the source. I have it. So we have our 3 times nested loop here, right? For going through the grid in each direction. And around that, we do 1,000 iterations.
So that's why 1,000 times copying.
Right.
I thought...
Because we call 1,000 times our kernel here. And at the beginning and the end of our kernel data is copied. Back to slides. I still would suggest first doing data scoping, then one. Yeah, I know. Maybe for some of you it's too slow, but I would do it. I would like to do it step by step.
Is there a reason why the map to P is separated from the map to every other variable?
No, it's just because.
It's just for the sake of clarity.
Yeah. So do you have more questions?
Just have a question. So equivalent of map for C will be?
It's also map.
It's also map, okay.
Yeah. I mean, that's the same. What is different is the pragma at the beginning and the line continuation in C, it's just with the slash. don't know how fast you are in typing, but then, I mean, I called it version 1A, and my result is that I get this one, bit faster, but still slower than the original code. Why? Yeah, I think we already got quite close to the point, right? Who of you also got that result? What did I do? Are there issues with the queue? What a pity. Right, it's still copying quite a lot of data. I mean, actually, could maybe, since I guess we need to wait quite a bit until the queue is fixed, I would suggest to go one little step further. So we were almost there. So we saw when we enable the runtime commentary, we saw that there's a lot of data copying. That's the first point. We reduced that already with doing the data scoping correctly. But we also saw that it's done very often. It's done for each time we call the kernel, so it's for each step of the iteration, which we realized is not really necessary. Which is not really necessary, since within or between our kernels we do not move that much data. So here on the slides I also put the output from the NVIDIA profiler, so it looks quite similar as we saw already yesterday.
The queue is back, so your job might have finished already.
So then, if we all made the data scoping correctly for the kernels, I would suggest, what we already mentioned, to create a data region around the iteration loop. In that way, we prevent copying the data forth and back for each time we call the kernel. We just copying the data at the beginning of the Jacobi routine. We copy the data on the GPU, and it stays on the GPU for all the cycles we do within our iteration loops. But there's one more thing we have to consider, since we do, where's my mouse? We do the data region around the iteration loop, starting here at the beginning, ending here after the end do. Now, the update of the P array need to be also done on the GPU. So we have to add another kernel here around this update loop, right? So, having a short look to the code, to show you where we are now. Let's take that one. So we have our iteration loop here. We want to add the data region around that one to prevent copying data for each time we call the kernel. We have the kernel then here, so the data is then for this kernel already on the GPU, So the compiler realized that, so the data do not need to be copied for that one. But down here, we have another triple nested loop to update array P with the actual results of the work 2 array, right? So one possibility could be we copy here at the end the data back to the CPU, do the update there, copy the data at the end back to the GPU, and then do the next iteration with the new data. Or, which would make more sense, do these update here of array P directly on the GPU. And therefore, we have to add another kernel. So we have to, excuse me? Then there's no synchronization. We just tell the compiler, okay, this operation also has to be done on the GPU. It's a kind of update operation acting on these array P, yes. But not from a data movement point of view. It's
so each thread is still updating its own part of P. It's not like.
So you ask if each thread updates each own part of P.
So at this point, we don't need to know what other threads did to P.
Yeah, we do not have to consider which threads acts on which part of P. That the compiler will take care of.
Yeah, but
we need to have a synchronization that all the threads are done with, where's my mouse now? That all the threads are done with applying on this work2 array, right? Creating values into there before we copy the work2 to P. So this synchronization anyways we get when we end our kernel here. So by creating another kernel around that loop, we verify that there's a synchronization in between.
And so it's possible theoretically that before thread 1 was doing something to some part of P, and now it will be doing something to some other part of P, or
right.
to some other indices.
Right. Which thread acts on which P, we don't care about it. Okay. What is not possible, I mean, what is not possible to take this line directly into here, since, I mean, then we could directly remove that one, because we act on shared memory data, and one thread could be faster than the other one, and we have a dependency on P here, so we cannot do that. We need a synchronization between. That's why we have two kernels.
Thank you.
More questions? I show maybe the slides again. File system is corrupted. That's live demo. Yeah, I like that. Any one of you is working on Lustre? What a pity. Lustre is a different file system, so then.
Yeah, to go on the Lustre file system, you should. There is an environment variable called scratch, so you can go cd there and check out the repository there or copy your stuff there.
No, actually, no, you can't do that since Git is working on your home directory for Git files.
Yeah. Apparently, we have a misbehaving user that runs jobs on the login nodes. So that's why it's not one of you. Eh?
So yes, we cannot act on the home file system since the file system is somehow corrupted. You cannot do anything, not an LS, no files viewing. Yeah, question time. It's question time.
No,
He's
because
first.
I missed out a part before the break because
Excuse
we had
me?
some. I missed out a part because we had I had some debugging issue here before the break. This ACC file you showed before. What modules do you have to be loaded for actually showing this one, or is it supposed to be?
Which file? The LST file?
You showed. When I mentally came back, you showed a file.
Excuse me. No, I can. Yeah, I have it on my slides. I can show you there. You mean that one?
Yes, that one. It's in the list.
Okay. That one, if you enable that, where is it? Where's my mouse? I hate that. If you enable these environment variable, Cray ACC debug equals 2, that output will be written directly into your standard output file.
Okay.
You can also use compute profile equals 1, which is the NVIDIA runtime commentary, which creates output which looks like that. So there you also have time spent for kernels, data movement, stuff like that in there. So it's quite similar output from different sources. I would not recommend to use both variables at the same time. That could conflict. There was another question here.
I did something different. So actually, I added the map options at the beginning of every loop. The map was allocate, which ended up that I don't have copying at all. So everything is both initialized and computed on the accelerator.
Where did you add the map allocate? Excuse me. At the beginning.
We have 4 loops. 2 loops in the initialization part, and 2 loops in the computation part.
Right.
There are a few arrays involved. So in front of every loop, I augmented the OMP command with the map directive, saying map for all the involved arrays to alloc, which basically means they stay on the GPU forever.
Yes.
Which is a good option because we can compute without any copying.
That's a really good idea to do that. That's what we will do in a few seconds, minutes maybe also an hour, I don't know. But the crucial part is, I mean, this is a really, really simple code. In a more complex code, you do maybe have not an overview of where your arrays are used on each places in your code. So then I would suggest to really start with the most crucial function or loops, adding the kernel there, and then going the call stack up, and then moving that data region, what we introduce now, the call tree up. You will see you will have to add more and more kernels to act on these data and doing all the stuff you do within your computation. But doing that all in one time, like you did it now, that could be quite complicated on a really complex code.
Well, typically I have few real-life GPU applications where I consider just the best practice. Keep everything on GPU. Move things to CPU only when it's really needed.
Okay, but
it's needed if you have to communicate something over MPI or you want to get the final result.
I mean, that's anyways the goal, to port more or less the whole application to the GPU. Yeah, I agree. But doing that all at once, that could be quite difficult. And you risk that you mess up something, and you risk that you get wrong results.
I'm ready to take this risk, just to reduce the
Yeah,
development time.
you are free to do that.
Yes, but the question was in the end. So now everything is allocated on GPU, so no copy takes place. But in the end, I want to get the final data.
Yeah, you
Although
need to copy
this
back.
program does not require this, all what we need here is just the checksum.
Right,
In the real life, I will need some final array.
right. Then you have to
P,
specify
P,
that
I
at the
guess.
end of your data region, the data is copied back to the CPU. Right.
I see. So that's something which would be interesting. Because now, yes, now I'm not using data regions at all. So I put explicit maps to every array.
Yeah, I wouldn't suggest it. I really
So
would
perhaps
suggest using data
that's not a
region
good
instead
practice.
of just saying allocated. Yes.
Okay, so once this file system comes back, I will try that.
Good.
Okay, thank you.
We all will try that, hopefully. More questions? It's question time. Something you did not understand? Something? Nothing? I know you all want to exercise, and I really appreciate that, but
Maybe we could clone into Scratch.
I tried that, but you cannot do a git clone since git acts on a file which is within your home directory. You could do that. Questions on that? No, there are no stupid questions.
Okay, so I already had this map to P in the part before, so now I delete the P there and put it further up.
So you mean,
The first
excuse me,
line.
where's my mouse? You already had the mapping within,
So this clauses is for the other 5 lines that we put in the first place.
excuse me?
So this clauses
Yes?
is representative for the 5 lines that we had before.
So you mean the data scoping for the first kernel we did in the previous step?
Yes?
Yes, you could leave it there. I would suggest leaving it there. But
the other
you,
things are additional. So the
yeah, and
map
do
to
that,
40.
the data scoping here and the data region again. Some you have to change, at least.
Which
What's
one?
happening with my mouse? Here we had to copy in and out everything, so you have to think of maybe something changes. So for example, here we need to do a copy to from P. No, we also had to do that in the other place. Did something change? All right. Here, in that kernel, right, we had to copy out the work2 array, since that was, I mean, we updated the work2 in that kernel, and here down in the next triple nested loops, where we now at the next kernel, we update P on basis of work. So in that kernel, we have to copy out work2 to then had it available doing that on the GPU in the previous version, right? Now, we keep the data of work2 on the GPU. We do the update there immediately. So for our data region, we just need to allocate memory and do not need to copy back any data of work2, right?
So
No, I think work2 was defined here at the beginning of the routine, Jacobi. I mean, I'm not sure about the C version, but for the word.
Now it's still outside of our data.
I mean, it has to be an, yeah, the actual definition of work 2, I just repeated, okay. The actual definition of work 2 has to be outside of these data regions, since acting on that data region with work 2, the compiler needs to know what data work 2 is. So which data type it is, which size it is, and so on. So therefore, it needs to be defined outside of the data region.
So that's the general rule?
Yes.
Any variable we are talking about in this map should be already declared before we do this? Okay.
You cannot declare it in the map without defining it outside of the data region.
But before we... So what if some variable is defined inside the loop, then I cannot say anything about that, what I want to do with...
Then you do not need to do the data scoping for that.
Because it will just stay on the GPU for it.
I mean, mostly you need, I mean, the most important thing is that you want to define which data needs to be copied to the GPU and back, right? And anyways, for data which is defined within the kernel, it's just needed for that kernel, so it's anyways just temporary variables on the GPU.
Yeah, thank you.
How this allocation will be in C, not
Excuse me?
in Fortran. In Fortran knows already about the size of the work 2 array.
Yeah.
Yes, and in C, how it would be in
You
C?
can specify with the start and end, start and length of the array.
Okay. Thanks.
From the 5 lines before in the first place, I can delete the one map from
Excuse me?
So from the 5 lines that we first wrote in the first place, I can delete the last line, map from work 2, since we put it in the upper part.
Anyways, you could delete all of the data scoping you now do in the data region. They are not necessary to do here anymore. But I would suggest, I mean, it's easier to leave them in, not deleting them, and it's more safe to leave it in. Since it could be when we now move the data region out of this function in another function, and we maybe want to call that Jacobi function from a different point of our code. Could be that there's no data region within there, and then we can be sure that our data scoping is still correct, leaving it there.
So if you do twice the same, it does not give an error?
No. I mean, even it would not be the same. You see, here we change from we had here work 2 copy from GPU, right? We wanted to copy out the temporarily results of work 2. Here we change to allocate, just to allocate work 2, since we do not need to copy anything back, since we already handle it here in the second kernel. So we change already the data scoping. This doesn't matter, since the compiler realized, starting that kernel, okay, the data is already on the GPU, so it's already handled here. Do not need to do anything. It's just working on work 2 if it's not defined before. So if it's not already on the GPU, with which data clause ever you did that, allocate, copying from to, whatever, then if it's not defined, then it's using the one you define here. If not, it's using the one you defined before.
So the second line is the same?
This second line here, right, with the map 2, yeah, it's the same, since we still need to copy to the GPU, array A, B, C, work 1, and the boundaries. That we defined before, so we need to copy it, in its initialized values to the GPU. At the later stage, hopefully, we could also do the initialization on the GPU, then we do not need to copy anything there, right? But so far, the initialization is done somewhere else on the CPU now, so we need to copy data.